All right, so this is notebook page 35. You all were supposed to copy this down yesterday and attempt to fill it in based on what we learned about parallel and perpendicular slopes. So I'm going to go through this really quickly. If our original line has a slope of -1/8, then our parallel line should be the same slope. And our perpendicular line, because this one is negative, our perpendicular line is going to be positive, and we're going to flip over that fraction, make it 8/1, or just plain 8. Over here, if our slope of our original line is +7, our parallel slope is also going to be 7. Our perpendicular slope then is going to be negative, and we're going to flip that over and make it 1/7. Our original slope here, -4/5, so our parallel slope is going to be the same. Our perpendicular slope is going to be a positive, and then we're going to flip the fraction over and make it 5/4. Now in this one, our slope is here, -9. So our slope is -9. Our parallel slope would be the same as that, and then our perpendicular slope would be a +1/9. All right, so the slope of this line is 2/3, which is right here. So the slope of a parallel line would be also 2/3, and then a -3/2 would be the perpendicular slope. This one, the slope is -7/8, so our parallel slope would also be -7/8, and our perpendicular slope would be a +8/7. Now down here, this is in standard form, so I can't find a slope like that, so I have to solve the equation, get y all by itself, get it into slope-intercept form. So I do that first. I'm going to subtract 4x from both sides. I'm going to put my 0x in here so I know where to subtract it. 9y equals +16, ignore that, minus 4x. Now I'm going to divide by 9. And so now I have my slope of -4/9. And then my perpendicular slope would be a +9/4. All right, these are the notes on page 36. You all were supposed to get these copied down, so I'm going to run through these blanks really quick. If you need, the notes are attached to the board. You can go take a picture of them, get them copied down in your notebooks, please. Page 36. So parallel lines, we've known for a long time, go forever in both directions, and they never touch. That's why their slopes have to be the same, because if their slopes were slightly different, they would eventually intersect. This right here, the little parallel lines, is the symbol for parallel. We would read this statement as line A is parallel to line B, and the slopes of parallel lines are always the same. Perpendicular lines, on the other hand, intersect at one point and at 90-degree angles to each other. Their slopes then are opposite signs, and they're reciprocals. That means we've taken the fraction sorry, can't spell that. That means we've taken the fraction and we flipped it upside down. So the symbol for perpendicular lines is this little upside down T. We would read this statement as line C is perpendicular to line D. And if we look at this example down here, if we're looking at an original line with a slope of -1/5, if line M is parallel to that, so the slope of line M would be the same since they're parallel. Now line K is perpendicular, so the slope of line K, instead of being negative, would be positive, and then we would flip this fraction upside down, and it would be 5/1, or just plain 5. Okay, so our next example, this is page 38, and I'm only going to ask you to do example number 2 for right now. We'll come back to example number 3 on Monday. The equation of line D is y equals -7/9x plus 6. Find the equation of a line that is parallel to D and goes through the point 18, -23. So we did this before where you were given the slope and given a point, and then you had to find the equation of the line. The only difference between what we're doing now and what we did then is in the past I gave you the slope. Now you have to figure the slope out yourself. So our information for our old line, we really don't care. We don't know what y is for our old line. We don't know what x is for the old line, but we don't really care about that. What we really care about is the slope. So the slope of our old line is -7/9, which means if they're parallel, the slope of our new line is also going to be -7/9. We know x and y because of this point up here, -23 and 18. We don't know b, but we can solve for b. So this is step 1. Just fill in your information. Step 2 is go back and substitute in your information, as much of it as you can, into the equation. Y equals -23, m is -7/9, x is 18, and we don't know b, but we're going to solve and find it. So I can reduce this down. -23 equals -7 times 2 plus b. So -23 equals -14 plus b. So if I add a 14 to both sides, I get +9 over here equals b. So my b now is 9. So the last and final step, step 3, is to go back to our equation, y equals mx plus b, and write the equation using information from the new line. We don't really care about this anymore. So y, we just leave as y because it can change. M is -7/9 times x, and then b we just figured out is 9. So this is the equation of our new line that is parallel to the old one. Now you're going to take this same concept and work on this handout here. You only have to do the parallel line side. Eventually this is going to become page 37 in your notebook. The other side is perpendicular lines. Don't worry about that until Monday. We'll do that together on Monday. But give this a shot. Even if you only get your chart filled in, get as far as you can on it, and help each other out, and we'll take a look at it together on Monday.